Hi, welcome to Chemistry edition of Darling Fish channel. My name is X-Coco and I'm excited to present to you a writing chemical formula. Now, how do we do this? We'll be looking at this in this lesson. Please kindly subscribe to this channel to see more of our presentation. Alright, if you are ready, then let's start. Before you write a chemical formula, you have to know the periodic table, the elements in there, and their charges. So this is a typical periodic table with some few elements and their charges. Then you also need to know radicals. We have already talked about this in the previous lesson. So we have the radicals here and their charges. Please take note of these radicals and their charges because we'll be using them. Now we need to know the names of the ions here: perchlorate, nitrite, sulfite, and you should be able to write these formulas. Now let's start. These are some of the tips we should remember. First question is the compound binary an acid, ion, or a salt? Because that is what you depend on to write a chemical formula. Know the valency of each element and that of the radicals as well. Now let's begin. So we have 6 examples here: sodium bromide, lead iron oxide, aluminium oxide, zinc iodide, vanadium 5 oxide, and iron 3 oxide. This is what you do. Before I take you through this, please, sodium, write the element down here. Bromide, it is Br. You have indicated that. Now let's move to the second one, Pb. Write it down. O, which is for oxide, you also do that. Let's move to the third one, Al for aluminium. So this is what we have to do when it comes to writing of chemical formula. Now with sodium bromide, we said we have sodium, we have bromine. But please take note of this. Before you put them together, you have to know their charge. So if it is sodium, you should be able to identify that the charge is +1. If it is bromine, you should be able to identify that the charge is -1 before you start. If it is having a number in a bracket, a typical example is Pb. We said it is lead 4. Then instead of using the normal charge that you know, you use that number in the bracket. So let's start with the first one. Na has a charge of 1. Br has a charge of -1. This and that will cancel. So we can say Na and Br will come together and that will give us NaBr. Now when you take the second one, the name was lead 4 oxide. Lead 4 oxide. We know oxygen has a charge of -2, which is indicated here. What about lead? Because we have 4, that is the number 4. Instead of we using the normal charge that we know, we pick the 4 which is inserted in the bracket. So we have the 4 here. This divided by that will give you 2, 1. 2, 1. Looking at the numbers here, they are not the same. This is 2 and the other one here is 1. So this 2 here will go to oxygen. 1 will go to Pb. But we don't write 1. So that will give you PbO2. So that should be a subscript over here. Take note of that. Now let's take that of aluminium oxide. This is aluminium with a charge of +3. That is oxygen with a charge of -2. The numbers here are not the same. So what will happen? They have to cross. So this 2 will be a subscript here. The 3 here will also be a subscript here. And that will give us Al2O3. Now let's look at zinc iodide. Zinc iodide here. Zinc here has a charge of +2. I a charge of 1. The two numbers here are not the same, so we have to go through the crossing. So 2 will go to this side, 1 will move to that. But as I said, we don't write 1. And that will give us ZnI2. Let's take that of vanadium 5. So it is vanadium 5. Please don't forget that if there is something in the bracket, that is what we consider vanadium 5. So that is V5. So when you do the crossing, you will get V2O5. Fe has a charge of 3. Oxygen, that is 2, because it was stated that it is ion 3. So crossing also give us Fe2O3. I hope you understand this. Now let's move to naming of oxo acids. But we want to see how we can write the chemical formula whenever you are given that. Now let's look at what we have here. Please take note of this. Whenever it is an acid, it is the presence of hydrogen here that will indicate that it is an acid. So take note of that. So you can write your H down whenever you see acid. Then you move from right to left. So we have tetra here, which is here. Tetra, which is the 4 here. You move to the next one. So it is like you going backwards. So tetra, which is 4 here. Oxo is oxygen. Sulfate is sulfur. And we all know that this tetrasulfate is a radical, which is SO4. What is the charge for SO4? That is 2. So I told you that we'll be using the charges for the radicals. SO4 here has a charge of 2. Hydrogen here is having a charge of 1. So what do? These two will cross to this side, then the 1 will move. But as I said, we don't write the 1. And that will give you H2SO4. For the radicals, please, we don't separate them. Take note of that. Now let's look at the second example. That is also an acid. So you put your hydrogen down, that is on your left of the screen. Then you take the radical. Tri is 3. That is what is indicated here. Oxo for O. Then we have bromate. So putting the two together will give us 1, 1, because Br O3 is having a charge of 1. That is -1. So it is not like the H2SO4 here. BrO- has a charge of 1. Good. Now let's look at the next one. We have this one to be an acid. So you put your H down. This is tetraoxophosphate 5 acid. So we go back again. Tetra for 4, oxo for O, then phosphate, we have P over here. We all know that the charge for this radical, which is PO4, should be 3. So it is 1 against 3. Because the numbers are not the same, what do? We do the crossing. So we have H3PO4. So please take note of that. If it is an acid, you should know that we have hydrogen on the left. Then you combine the radical, and you should know the charge for each of the radicals. Now let's take that of ions. Now let's look at how to write chemical formula for ions. So in our case here, we have tetraoxosulfate Vi ion. The ion here indicates that there should be a charge. So how do we do this? Please take note of this. Whenever you are given an ion, we move from right to left. So in you writing, what you have to do, you start with the number here. So as it is indicated here, tetra for 4. Then you move to oxo, which is also here. Then the sulfate, which is S here, is also indicated. Now we want to see the charge which is on this ion. There's a simple way out. What you do is you multiply the oxygen number here, which is 2, by 4, which is here, and that will give you 8. So what number can be taken from this 8 to give us 6? And that is minus 2. So that is why we have minus 2 here, or 2 minus here. So 2 times 4 minus 2 should be able to give you the 6 here. Let's try with this one. So we go trioxocarbonate. So we have 3 oxygen carbon. All right. Now we have 4 here in the name. Ivan. How do we get Ivan? Now let's multiply. 2 times 3 will give us 6. A number can be taken from this 6, and that will give us 4. And that number is 2. That is minus 2. So we have 2 times 3 minus 2, and that will give you your 4. So that tells you that the charge here is 2 minus. Let's try with the third one. So as I said, we are going backwards. So from right to left. So we have tetra, which is 4 here. Oxo is also here. Phosphate, which is a P here. Now from the compound, we have V here, which is 5. We all know that oxygen is 2 here. So 2 here times 4 will give us 8. What number can be taken from this for us to get this 5? Now when we subtract this 8, that is 3 minus 8, we are going to get our 5. So 2 for 8 minus 3 will give you V. Alright, so that is how we determine the charge. So that is why we have 3 minus here. Now let's move to the salts here. We have potassium tetraoxomanganate 7. Please take note of this. You see, I have indicated with blue the cations. The tetraoxo something, they are the radicals. Take note of that. So you separate the radical from the cation. So we start. This is potassium, that is K over here. As I said, we move backwards. So tetra, which is 4 here. Oxo, that is what we have here. Manganate, which is Mn. Now there's a question that we need to ask ourselves. MnO4, that is a radical. What is the charge? It is minus 1. We are not interested in the minus sign here. Now when you pick K, that is 1. So it seems that this is 1, that is also 1. And they have the same number. So K and MnO4 can combine to give us KMnO4. Now when you take copper 2, so per the name copper 2, which indicates that copper has a charge of 2. So let's look at that of the radical, which is tetra, which is 4 here. Oxo, that is oxygen here. Sulfate, and that is what we have over here. So we have Cu against SO4. How do we know the charge for SO4? Cs equals minus 2. So this is SO4. The charge is 2. Copper has a charge of 2. So this and that can cancel. So you will get CuSO4. Now let's look at magnesium tetraoxophosphate 5. Magnesium from the periodic table has a charge of 2. This is a radical tetraoxophosphate 5, which is PO4. The PO4 here has a charge of minus 3. So we have 2 and 3 here. Are the numbers the same? No. So if the numbers are not the same, what do? You cross. So these 2 will come here. Then the 3 also come here. That should be a subscript. So that is how come we had MG3 here to bracket PO4 subscript 2. Now let's look at the last one. We have lead 3-trioxynitrate 5. So the name is lead here, which is a PB. 3 here indicates the charge of this element. So that is the 3 over here. Trioxynitrate. So we have 3 for tri, oxo for oxygen. That is what is indicated here. Then nitrate we have N. But we all know that with NO3, the charge is minus 1. PB has a charge of plus 3. As I said, we are not interested in the positive and the negative side. So because the numbers are not the same, 3 here will move to NO3. 1 here will come here, but that is not written. So at the end, you have PB into bracket. We have NO3 here, subscript 3. NO3 is in a bracket because it is a radical. We cannot separate them. Thanks for watching. Please don't forget to subscribe for more videos.